Let's go. If you watch this, you're going to know all about dams. Dam is just a barrier that runs across a river or stream to control the flow of water. Water stored behind the dam in a large body of water that we call a reservoir. Dams hold water for a whole bunch of different reasons, but it could be for human consumption, it could be for generation of electricity, it could even be for flood control or recreation, for people to go take their boats into the lake and go have some fun. In 2009, there were 845,000 dams in the world. And in the U.S. specifically, there were 82,642 dams. The largest reservoir system in the United States is along the Missouri River, and they have 6 dams and reservoirs in Montana, North Dakota, South Dakota, and Nebraska. Missouri River sources nearly 24 trillion gallons of water. So there you go. Fun fact. Dams provide lots and lots of benefits to humans, but they come with lots of different costs. Financial costs, societal costs, environmental costs. The world's largest dam is the Three Gorges Dam, right? It's built in China across the Yangtze River. The dam is huge. The dam is huge. It's 1.3 miles wide. It's 610 feet tall. It has a reservoir behind it that is 410 miles long. And the Three Gorges Dam took 13 years to build and 2 years for the reservoir to fill up with water. So when we build dams, just like when we build any other large-scale construction, it takes tons and tons of energy and materials, and it displaces people, right? The Three Gorges Dam was created along with its reservoir. It flooded 13 cities, 140 towns, 1,350 villages, and it forced more than 1.3 million people to be relocated. One of the biggest benefits of the dam is the large amount of electricity that's generated through hydroelectric power rather than burning fossil fuels. For migrating fish like salmon, dams present an obstacle. When we lose fish like that, it can have a cascading effect on other organisms that can depend on them, like the bears that feed on migrating salmon. So one of the things that we do for salmon who have to migrate upriver, I'll explain that in class, is we build fish ladders. Look at this right here. Okay, so they're basically like a set of stairs with water flowing over them, and the salmon literally jump up the ladder to get upstream. These migrating fish can swim up the fish ladders and they can reach their traditional breeding grounds. So I'll show you guys a video of this in class. I don't want to put it on here because of, I don't know, I'll probably get sued or something. But it's really cool to see. Also sad because they shouldn't have to be doing that. But whatever. There's a whole bunch of other methods that we've designed now to try to more easily get fish over dams, and I'll show you some of those too. So levees, dams, and dikes, those are all things that are designed to hold water back from its normal course. But for hundreds and hundreds of years, not only have we stored water, but we've also needed to move water. So let's talk about aqueducts. Aqueducts are basically canals or ditches that are used to carry water from one location to another. Usually aqueducts remove water from a lake or a river, and then they transfer that water to where it's needed. We usually associate aqueducts with the Roman Empire, but they date all the way back to at least the 7th century BCE in Greece. So in the United States, 2 of the country's largest cities, New York and Los Angeles, are dependent on aqueducts for their daily water needs. Okay, maybe you didn't know this, but the Catskill Aqueduct brings clean, fresh water over 120 miles from the Catskill Mountains to New York City. And the Colorado River Aqueduct takes water from the Colorado River and carries it about 250 miles to Los Angeles. There are lots of trade-offs and environmental costs associated with aqueducts. On one hand, it's a good thing that we can get water from one area to another area to people who need it, but it also disturbs and fragments natural habitats. So even if an aqueduct is an underground pipeline, a great deal of disruption occurs during the construction process. If we're diverting water from a natural river, that basically means there's less water flowing where water has flown for millennia, right? It's an unnatural thing. So a lot of our major rivers in the United States, including the Colorado River, the Rio Grande, now they're frequently having periods during which there's so much water removed from them at multiple locations that they go dry before they even reach the ocean. This is really bad too, because when there's less fresh water entering an estuary, that means that the ocean water is going to move further up into the river. And there's all sorts of problems associated with that, but The influx of seawater is going to raise the salinity of the estuary, and it's going to harm the aquatic life that's not adapted to the salty water, and all sorts of other problems will ensue. I just threw this picture in here because it is a picture of the Colorado River, and it is one of the most beautiful rivers you can ever see. So the thought of it drying up before our eyes is very, very sad. Okay, what about this one? One of you guys put this on that Ed puzzle as one of your jokes. I can't remember who gave me it, but what is fast, loud, and crunchy? A rocket ship. Here's a map. It's showing the Colorado River Basin Project. The Colorado River provides water to like 40 million people. There's 15 dams throughout the entire river. So the Colorado River is providing water to all sorts of big cities like Las Vegas, Los Angeles, Phoenix, Tucson. You might not think about it, but years ago, not many people lived in Phoenix and Tucson. But ever since we had this ability to take water from the Colorado River and take it there, to Phoenix and Tucson, the populations went up. And so it's going to be a big problem in the future when we have used so much water in the Colorado River. I don't know what's going to happen. We'll see. Here's another picture of the aqueducts for you to see. You can tell, obviously, that they're man-made. At least we got some wind turbines down here. Oh, right there. Another really, really famous river diversion project that happened, dare I say infamous river diversion project, was in the 1950s when the Soviet Union diverted two rivers that fed into the Aral Sea in Central Asia. So what happened was when they diverted the rivers, it dramatically decreased the freshwater input that was going into the Aral Sea. Therefore, the salinity of the remaining lake water increased, and it destroyed the local fish populations. The Aral Sea was originally the fourth largest lake in the world in terms of surface area, and this diversion project reduced its surface area by more than 60%. And I'll show you a picture here in a second, but the withdrawal of the water caused the Aral Sea to be split into two different parts. There's the North Aral Sea and there's the South Aral Sea. But all sorts of crazy things ensued. Dust storms have eroded the soil. Salt and pesticide residues from the lake bed that's really, really dry, they can carry particles of those substances to the atmosphere. The lake size reduction has also affected the local climate because without the climate moderating effect of a large body of water, summers in the region are now a lot hotter and the winters are a lot colder. There are some efforts being made to save the North Aral Sea, but saving the South Aral Sea has basically just been deemed too expensive and all the efforts have been abandoned. But the Aral Sea is still drying and the South Aral Sea is nearly gone. If you guys Google this, you can see all sorts of pictures where it's basically dried up. And so here's one example, but here is a time lapse, and I'm going to show you that video in class, but this is showing the picture on the left being in 1989, and the picture on the right is actually from 2014. So there are still probably even more recent pictures, but I mean, you can see this whole area is just gone. So it's really, really crazy. Okay, let's talk about some fun stuff, right? One of the ways a lot of water-poor countries are getting fresh water is by removing the salt from salt water, right? It's a process that's called desalination. It's also called desalinization. Right now, the countries of the Middle East produce about 50% of the world's desalinated water. So there's two really common desalination techniques. There is distillation, which I will explain, and then there is reverse osmosis. Distillation is really simple. So during distillation, basically we just use heat to boil water, and it leaves salts behind as it evaporates. Steam that is produced is collected and condensed, and it gives us pure water. A lot of energy is required to boil that water and then to condense it, so distillation is a really economically and environmentally expensive process, so it's not super ideal. A better method is the second one here called reverse osmosis. This is a little fancier and a little more involved, but in reverse osmosis is salt water goes through this hole right here, right? And you've got pressure applied to the water here. This thing right here is a semi-permeable membrane. So the water is pushed through this at high pressure. And what happens is the water molecules are able to get through this membrane, but the salt is not. And you end up getting very pure salt-free water here. And out the other tube here goes the brine, which is a really, really salty water that's left over. When I used to live on the sailboat in the Caribbean, we got all of our water from reverse osmosis. So we were constantly pumping in salt water from the ocean. And then the water that we got out of our taps was, water from that. So that's pretty cool. So reverse osmosis is a newer technology. It's a lot more efficient and it's less costly than distillation. But that liquid that remains that we call brine, brine, has a really, really high salt concentration. And we can't deposit that salt concentration on land because it could impact the soil, it could contaminate the soil, and it could potentially harm animal life. And if we just dump it into a coastal area, it could harm the fish there and other aquatic life. So right now, usually they dump brine back into the open ocean, even though its high salt concentrations can still cause harm to, localized ocean life, which is a problem. Overall, all of these water management systems require a large investment to build, to maintain them, to repair them. This means that a lot of these water-poor countries are not able to implement these large-scale methods of water management to provide for their needs. The United Nations estimates right now that there are nearly over 2 billion people that live in regions that have a scarcity of water, and they're expecting that number to go up. Hey, oil, want to hang out? I can't mix with you guys. Hydrophobe. Last but not least, okay, now let's talk about how water is used by humans for agriculture and industry and our household needs, stuff like that. Not only is water really, really important for us to have, if we don't have it, we'll die, it's important for us to produce food. Like we talked about 70% of our world's fresh water is used for agriculture specifically. The other 30% we split between industrial and household uses. The last 50 years, as our agricultural output has had to keep up with the human population growth, the amount of water that we've used for irrigation all throughout the world has doubled. About 30% of the water we use for agriculture is used specifically for irrigation. Okay, so if you don't know what irrigation means, this is how we water crops. And there's a whole bunch of different ways for us to do it. Basically, agriculture presents the greatest potential for us to conserve water by changing our irrigation practices. Okay, so there's 4 major techniques that you guys should be familiar with. And those are furrow irrigation, flood irrigation, you've got spray irrigation, and drip irrigation. The oldest technique that we use is called furrow irrigation. It's really easy, it's inexpensive. This is basically when the farmer digs trenches or furrows along the crop rows and fills them with water. That water then seeps into the ground and it provides moisture to plant roots. Okay, so when we talk about furrow irrigation, it's about 65% efficient, which means 65% of the water is accessible to the plants, and the other 35% of the water either runs off the field or it evaporates. So that's not that great, right? The second technique is called flood irrigation, which is exactly what it sounds like, but it involves flooding an entire field with water and letting that water soak in evenly. This technique is usually more disruptive to plant growth than furrow irrigation, but is slightly more efficient, and that efficiency ranges from about 70 to 80%. Spray irrigation is the third type that you should know. It's a lot more expensive than furrow or flood irrigation, and it also uses a fair amount of energy. This is when water is pumped from a well and into an apparatus that contains a series of spray nozzles that spray water across the field, basically like giant lawn sprinklers. When we talked about center pivot irrigators, this would be an example of spray irrigation. The advantage of spray irrigation is that it's 75 to 95% efficient, so that number gets up there pretty high. The last type of irrigation you guys should know is drip irrigation. It uses a slow dripping hose that's either laid on the ground or it's buried beneath the soil. Irrigation using those buried hoses is over 95% efficient. It also has the added benefit of reducing weed growth because the surface of the soil remains dry, and that reduces the weed germination. These drip irrigation systems are particularly useful in fields that contain perennial crops, so things like orchard trees, where the hoses don't have to be moved for the annual working of the field. Just like all human activities, the trade-offs that are involved with each irrigation technique, they got to be weighed to determine the best solution for each situation. Another really cool alternative type of agriculture is called hydroponic agriculture. Hydroponic agriculture is the cultivation of crop plants under greenhouse conditions. The roots are immersed in a nutrient-rich solution, but there's no soil involved. So basically, water that's not taken up by the plants can be reused, and this method uses up to 95% less water than traditional irrigation techniques. Hydroponic operations can produce more crops per hectare than our traditional farming methods. Another reason why they're so awesome is because we can grow the crops during ideal conditions, we can grow them any time of the year, and we can use little to no pesticides. I mean, win, 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 win. Hydroponic agriculture is growing in popularity a lot, especially for vegetables. Hydroponic tomatoes have won lots of awards for their flavor. Even though it might cost a little bit more right now to grow vegetables hydroponically, a lot of consumers appear to be willing to pay the price for it. There are a lot of large hydroponic farms in Georgia and all over Europe. My cousin up in Iowa, he has a hydroponic tomato farm. So my parents always get his tomatoes from his hydroponic tomato farm, and they are super good. So I don't know. There you go. Fun times. How does the ocean say hello? It waves. Ha! You've all heard that. The main thing you guys need to know about water and industry is that the industry is the second largest user of water worldwide. Exactly what it says here. According to the U.S. Geological Survey, approximately 10% of all the water used in the United States is used in homes. The quantity of water used in households depends greatly on the types of infrastructure available in the country. A household water use depends a lot on where you're from and where you live. An average individual in the United States might use 157 gallons a day directly, but somebody in Kenya might be using more like 11 gallons per day. In the United States, more or less, our indoor use of water is pretty similar. If you're talking about outdoor water use, on the other hand, so watering lawns, washing cars, filling swimming pools, those numbers vary a lot across the United States by region. So in Texas or in California, a typical household uses about 6 times more water outdoors than the typical family from Pennsylvania or Iowa, because we have swimming pools and we have other things like that here. Last but not least, water ownership. It's a gray area. For water ownership and the future of water availability are going to depend on lots of different things, including how we resolve issues of water ownership and how we improve our water conservation and development to do water-saving technologies as the world's population grows. Water is an essential resource that we need, but who actually owns it, right? So like we talked about in class, it turns out this is a really, really complex question. In a particular area, multiple interest groups can claim a right to use and consume the water, but having a right to use the water is not the same as owning it. For example, regional and national governments often set priorities for water distribution, but of course they have no control over whether a particular year will bring an abundance of rain and snow, etc., etc. All throughout the world, the issues of water rights and ownership have created lots and lots of different conflicts. One solution that's been proposed by economists is to allow all the interested parties to openly compete for water and let the market forces determine its price. And that way they argued that water could be owned, but the true value of water would be realized and it would be paid for. In 1981, a free market system of water distribution was initiated in Chile. So even though water is public property, Chile allows individuals and corporations to buy and sell water. But the idea behind this approach was that buying water would encourage more efficient use, right? If you have to spend more money on it, you're going to use less of it. And even though those market forces, they can be useful in determining the appropriate distribution of water among competing needs, government oversight helps to ensure that the needs of the people and the environment are balanced with the needs of private corporations. So as long as that's clean and not corrupt, on paper it could work, right? But when you have some corruption going on and private corporations own all of the water, we'll talk about that in class. I just think this is so adorable. In recent years, a lot of developed countries have begun to find ways to use water more efficiently using technology, like in water fixtures, faucets, washing machines, and stuff like that. In 1994, there was a new federal standard issued for toilets and shower heads in the United States. A toilet manufactured before 1994 used 7 gallons of water per flush, but a toilet sold after January 1994 used 1.6 gallons per flush, which is like 78% reduction in water use. The thing with this is if your house is older than 1994 and you haven't redone your bathroom, you have one of these older toilets still. There's a lot of different countries like Australia, all over Europe, all over Asia. They've moved to these dual flush toilets. It's also becoming more popular in the United States, but this type of toilet allows you to push a button. So you can give it a 6-liter flush to remove solid waste, or you can give it a 3-liter flush to remove liquid waste. In the United States, we really work to improve the efficiency in our shower heads and our washing machines. For example, a 10-minute shower with an older shower head may have used 40 gallons of water, but the revised federal standards for new reduced flow shower heads call for a 10-minute shower to use no more than 25 gallons, which is a 37% reduction in water use. Washing machines aren't subject to the new federal standards, but newer, more efficient front-loading washing machines are now available for people to buy, even though they cost about twice the price to purchase. So, in some regions of the U.S., homeowners have been encouraged or even required to plant vegetation that's appropriate to local habitat. This is a term called xeriscaping, xeriscaping. For example, the city of Las Vegas, Nevada, it paid homeowners to remove the grass from their lawns and replace it with more water-efficient native landscaping. It makes sense. Vegetation substitution can result in a savings of 2 grams per water per square meter, or 520 gallons of water per 10 square feet of lawn per year. There are lots of simple ways to conserve water that can be used throughout the world. An example of this is installing a gutter system on the roof of your home and collecting rainwater, right? You can channel it into rain barrels or a large underground tank, and you can use that later to water your garden or whatever you may need. The world's growing population and the expansion of irrigated agriculture has increased our global water withdrawals more than 5-fold in the past 100 years. Global water use is expected to continue to grow with the human population through the early part of the century. Despite the United States and our growing population, our withdrawals in the U.S. have leveled off since they peaked in 1980. They think this is largely a result of greater water use efficiency in agricultural irrigation, in our electricity generation, and in our household use. So that's a good thing. All right, here is your riddle for this Ed puzzled. How is 7 different from the rest of the numbers between 1 and 10? Try to figure it out and I'll tell you the answer in class. All right, I hope you guys have an awesome day. I just want you to know that you rock and you rule. Bye.